The question of whether we are alone in the universe has driven human curiosity for centuries. It's a mystery that has inspired not only science but philosophy, art, and dreams across generations. And now, a fleet of rovers crawling across the dusty plains of Mars might be edging us closer than ever to an answer. With each turn of its wheels and every core drilled into Martian rock, NASA's Perseverance rover is laying the groundwork for what could be the most profound scientific discovery of our time, evidence that life, even in its most primitive form, once existed on another planet. It's hard to overstate the magnitude of what this mission represents. Perseverance isn't just gathering rocks, it's collecting a narrative, layer by ancient layer, of Mars' hidden past. These rocks are potential time capsules, preserving snapshots from a period billions of years ago when the red planet may not have been red at all, but blue and green, alive with rivers, lakes, and possibly microbial life. The hope is that within the minerals and sediments now tucked safely in sample tubes aboard the rover, we'll find molecular fingerprints of life or conditions ripe for its emergence. And that hope is not without basis. Mars, after all, is not a completely alien world. It shares a history with Earth in more ways than many people realize. Rocks gathered from the delta region of Jezero Crater, the former bed of what was likely an ancient lake, are some of the most promising in terms of biological potential. When scientists describe this area, they speak in terms that feel strangely terrestrial: river deltas, muddy lake bottoms, layers of sediment, and even the organic goo that might have washed in and settled over millennia. In these silted environments on Earth, microbial life thrives, dies, and fossilizes, leaving behind chemical signatures that last for eons. What Perseverance is now holding on to are samples from what could be Mars' own version of a fossil bed. If life existed there, even for a fleeting window of planetary history, those rocks could still bear the molecular scars of its existence. What makes this mission particularly exciting is how deliberate and methodical the process is. Unlike earlier missions where rovers merely analyzed Martian soil in situ, Perseverance is collecting and sealing samples that may one day be returned to Earth for detailed analysis in state-of-the-art laboratories. That next step, bringing Martian material back across the void, is the boldest part of the Mars sample return mission, and though it's still years away, it holds the potential to transform everything we think we know about biology, evolution, and our place in the cosmos. The crater floor samples, meanwhile, offer a different kind of treasure, the key to understanding Mars' geologic and atmospheric history. By studying igneous rocks, which were once molten, scientists can determine the age of the formations and link them to major planetary events, such as volcanic activity and the loss of Mars' magnetic field. Understanding when the delta was active helps narrow down the window in which life might have existed. More than that, it could reveal why Mars changed, why it went from potentially habitable to the dry, irradiated shell it is today. This doesn't just tell us about Mars. It tells us about Earth, too. By studying the failure of Mars' climate systems and its internal geodynamics, we're learning what safeguards our own biosphere and how fragile planetary habitability really is. This work underscores how extraordinary and precarious Earth's own balance is, reinforcing the value of stewardship and scientific vigilance. But there's an emotional current running through this mission as well. The sight of a solitary robot inching across a barren planet, methodically gathering clues to an ancient puzzle, captures a uniquely human spirit, our willingness to seek, to wonder, and to reach beyond what we know. It's a symbol of hope, not just for answering scientific questions, but for what's still possible when curiosity and perseverance align. The risks are real, of course. Returning samples to Earth from over 100 million miles away is an immense technical challenge. And it's possible we'll find nothing definitively alive in those tubes. No fossilized microbes, no unmistakable biosignatures. But even that, in itself, would be a valuable answer. It would force us to ask deeper questions about the rarity of life and whether we might still find it elsewhere, perhaps under the ice of Europa or within the clouds of Venus. What the Mars Sample Return Project embodies is a leap forward not just in planetary science, but in our collective understanding of life as a cosmic phenomenon. If even a few amino acids or preserved organics are found, It will radically reshape our view of the universe, from a cold expanse of sterile rock and gas to a place where life may be a natural outcome under the right conditions. In the end, the Perseverance rover is doing far more than gathering dust and rock. It's helping write the first chapter of what might one day be the most consequential story ever told: that life is not unique to Earth, that we are not alone, and that the universe is far more alive than we ever dared to imagine.